on the and I'll put it on the YouTube channel. So if you have that marked, I'll highlight it. So I'll put that up there. The test next week, I just finished making the multiple choice version. There's 18 questions, and I'll set a time limit on it of 1 hour. So that's a little more than time and a half of what I would normally give you. So that should cover anybody with that gets extended time, and I'm just doing that for everybody. Admittedly, usually you would get 36 minutes to do 18 questions. The multiple choice questions are about 2 minutes a question is how they put it in there. So you know, we've only had, so just know that that's how that works. So that'll open up at midnight on Wednesday. Okay, so that's when that will open up, and you can do it anytime from midnight Wednesday. You know, I'd like you to do it by Friday, but by Friday morning. But it will be opened up all the way till I left it open till like 7:30 in the morning on the Monday after spring break. And then it's going to be closed. Okay. So what questions, those of you who did the problems, what questions do you have that you would like me to do? So right now I got 2, 3, and 15. And I'll do those. I'll do any of them, right? I mean, I think I maybe can get through all 12. Even if I don't finish them, if I just start them, I should be able to get through a lot. And if you didn't do them, you know, I guess you can stay on here if you want to watch me do it, or you can take off and do the work. But you got to get the work done, folks. I mean, that's the bottom line. You got to do the work. Anybody in here have any problems? One? Okay.
Well, Chris, where are you posting the recording?
I'll put it on the YouTube channel that I always put it on. So if you go to lecture notes on Schoology, you can go to the YouTube channel, and I'll put it in this unit's folder. Put it in there somewhere.
Thank you.
Mm-hmm.
Have a great weekend.
Yeah, you too.
Bye.
Bye. Okay, so right now I got 1, 2, 3, 8, 10, 15 is the ones that I'm gonna do. That should get us covered. If I get through all those and you have more, you can let me know. I'm gonna share my screen. Those of you that are in here, you should be able to just see it up here. Let me open the chat up. So really, you're gonna, I mean, I'll do my best to monitor the chat, but really good if you stop me, and I'm gonna have a hard time seeing that. So let me see. I might get out of the screen. So you're just gonna have to unmute yourself, I think. So on this one, first of all, you see that little calculator up in the corner, you know it's a calculator question. So you know that that's a calculator question. And then it kind of goes through here and says, it's known that F is increasing. That's an important piece, you know, knowing that the graph is going up on the interval 1 to 7. And you wouldn't have to, you don't have to do this by hand, but it's asking you, what if you, but you should probably write it out. What if you do a right Riemann sum to approximate from 1 to 7 using 3 subintervals of equal length, okay? So when we think about what that looks like, when I think about what that looks like, here's what I pictured. I picture some kind of graph, and I picture that graph increasing. And I'm going from 1 to 7. And I'm using the right Riemann sum. So that's a span of 6, and I'm going to do 3 subintervals. So each subinterval has a width of 2. Does that make sense? If you guys stop me if you don't, I'm just not going to say it. Does that make sense? Just stop me if you don't understand it. So the right Riemann sum would be that one, and that one, and that one. So right away, you know it's an overestimate, okay? Because it's an increasing function, a right Riemann sum. So, you know, just with that, you know that you can get rid of A and C. I mean, like you got a 50% shot just knowing it's the right Riemann sum on an increasing graph. You got a 50-50 shot. But then you got to figure out, well, which one is it? Which one is it, B or D? So what we have to do is we have to kind of think about how would we come up with the area of this? Well, knowing that this is right here is f of x. So that's f of x. And f of x in this case is that function. So each of these have a span of 2 this way. So like the area of this one is 2 times f of 7. The area of this one is 2 times f of 5. And the area of this one is 2 times f of 3. And then you'd add these 3 things up, right? You just add those 3 things up. I wrote that sideways, I should write it like this, but you're going to add those. Now, how do you find those? Here's the way and this is why you have to use a calculator. Number one, you know you're going to have to use a calculator because nobody would ask you to estimate to the thousandth place. So you know you got to use a calculator on it. So if I do this first one, let's just call it A, B, and C, and I'll just figure out one of them, and then I'll let you go through the calculations for the rest of it. But if I'm looking at the area of A, it would be 2 times f of 3. So I do need to take my calculator and do 2 times, and this equation is, so I got 3 squared plus 1 over the square root of 3 plus 3, if I'm reading that right, plus 5. Admittedly, it's really small on my screen and not very easy to see. But if I wrote that equation right, I'd have that one. And then I'd find f of 5 and do 2 times f of 5. And then I do 2 times f of 7. And whatever that comes out to be would be my answer. But really, what's really kind of an important piece to note is if you know it's an increasing graph and you're using the right Riemann sum, you actually have reduced it to a 50-50 shot just with that knowledge. Okay, so but then you could go through and do those calculations, and that should be relatively easy from there. Any questions on that before I move on? And if you're like, well, I still didn't understand it, you got to stop me and I'll try to explain it a different way. Okay, so you have to be able to stop me, and then I'll do my best to explain it another way. So if I go to number 2, and that's a little glitchy, so hopefully I won't. So on this one, let me get over here so I can read it. It's known that you got f of x being that x squared minus e to the x. Again, you see those answers and you know it's going to be, you have to use a calculator on it. It's known that the integral from 0 to 1 is equal to that decimal if the midpoint Riemann sum with 2 intervals of equal length is used to approximate this. What's the absolute difference between the approximation and that other one? Well, so you just have to do a subtraction on this. Absolute difference means that it's always going to be positive. So that's why all the values are positive. But what we have to do is really similar to the last one is, and I don't know what the graph necessarily looks like. You could certainly graph it, but you wouldn't necessarily have to graph it. But what you do have to know is, let's pretend that this is the graph of f of x. I don't know if it is, but let's just pretend it is. So this is x squared times e to the negative x. You wouldn't necessarily have to know that that's a picture of the graph, but if this was, and we're going from 0 here out to 1 here, so we're going out to there, and we're supposed to use the midpoint Riemann sum, and we're doing, whoops, I don't want to do that. We're doing 2 subintervals, okay? So halfway between is 1/2, but we're using the midpoint Riemann sum, which means that this is 1/4, and this is 3/4. And so the midpoint Riemann sum would be that rectangle. And I'll make a dotted line with this one so you know that I'm using that rectangle, and I'm using that rectangle. So we're using those 2 rectangles. So if you think about like each of these rectangles, if I call this this one rectangle A and this one rectangle B, then we could do that the integral from 0 to 1 of f of x dx is equal to rectangle A plus is roughly equal to rectangle A plus rectangle B. And then we're going to subtract them from that value that they gave us to figure out what do we get for the approximation. Well, notice that each one of these has a width of, like if I just look at rectangle A, I have a width of 1/2, and the height comes off of that this is f of x up here, and here's what we have for f of x. So similar to what we did on the last one, rectangle A is 0.5 squared times e to the negative 0.5. Or no, not 0.5, 0.25, right? Because it's 1/4, 0.25, because that's midway. And rectangle B also has a width of 0.5, but now we use 0.75 squared times e to the negative 0.75. And then we just add those, take that calculation, subtract it from the given one, and you could do it in either way. You're going to get the same value. You just have to know you're just ignoring the negative because it's the absolute difference. Any questions on that? I'm going to move on to 3 then. Let me go to 3. Again, you get a calculator on it. And I mean, even if you didn't know, if you didn't recognize that this was a calculator question, you could recognize it just based on the fact that it's the answers are 3 decimal places. So if the answers are 3 decimal places, you know, well, I can't do that in my head. I got to use a calculator for it.
The calculator stopped working in the middle of, like, I tried to put in the equation and the calculator stopped working because of it.
Oh, because of the equation?
Yeah.
Yeah. So if you try to put that whole thing in there with the integral, that's on purpose that the calculator stops working because you overload the calculator. So we have to think about it in a different way. So let's talk about how we could do it. So think about this one. You got this function g of x, and you're supposed to figure out when g attains a relative. Is this a maximum? Maximum. So here's what I would do is I would say, okay, if I'm looking at g, which is equal to this integral of f, then this is g prime, which is just equal to f, right? And for what we've talked about with relative maximums, if this is increasing, this is positive. If this is decreasing, this is negative. And relative maximums are when we're going from an increasing function to a decreasing function. So we're, in this case, it would be really much easier for us to figure out, shoot, I thought I was showing you this. It would be really much easier for us to figure out when is the derivative going from increased or from positive values to negative values. So what I would want you to do is just graph. So before I do that, so if g of x is equal to, I'll flip it back, but I got to flip over to see what g of x is. So it's the integral from -1 to x of -1/2 plus cosine, I think that's a t squared plus 2t, but admittedly I'm having a little hard time seeing it. If you try to graph, if you try to put this thing all in your calculator will get bogged down. It doesn't have enough random access memory to do those calculations and graph that. But what you should know is you should know that g prime is just equal to -1/2 plus cosine t squared plus 2t. Now your calculator can graph that. And if you were to graph this, we just need to figure out when does this graph go from positive values above the x-axis to negative values below the x-axis. Rarely is there going to be a question on this exam that you don't have to do some kind of calculus. Rarely are you going to just be able to plug something in. AP purposefully writes an equation like that I boxed in green, that if you try to do that on the calculator technology that you have access to, you cannot do it. It will bog down on you. And that's by design. So you had to know, oh, well, if I just take the derivative, I'm going to get it. Uh-oh. I hope I didn't just lose it. Can you guys still see my screen online?
Yeah.
Well, if you're in person here, I am overloading the Wi-Fi right now. So I may need to cut out Apple TV and just make you go on to Zoom, unfortunately, okay? So I'm sorry about that for those of you that are on here, that I don't rather not you having to go on there, but at this point, I'd rather ditch that and save this recording than do anything else. So what I'm gonna do, so hold on a second. Okay, so I'll share it again in a second. I just wanted to get that out of there before we get on. So let me rearrange things again here a second. For those of you that are here still, let's see. This over here. So if you guys jump on, I will, if you're still wanting, I'll start sharing it off of this monitor, okay? All right, sorry about that. Let me share this again. There we go. So you guys can see my screen again now, right?
Yeah, we can.
Perfect, thank you. Okay, and let me go back to the chat. I was worried I was gonna. I don't even know if I'm recording anymore. Does anybody know if I'm recording anymore?
It says you still are.
Oh, perfect. I am. Sometimes with some of the things I can't see it. So there we go. Okay.
Mr. Office, I just have a quick question.
Yeah.
On the AP test, do you get a calculator for the whole thing, or is there like certain part where you get a calculator and then certain part where you don't?
So that's a good question. So the question for you guys is on the AP exam. Do you get a calculator on the whole thing? And the answer is no, you don't get a calculator on the whole thing. But what you do get is you get the first part is 30 questions, 60 minutes, no calculator. Then you get, and multiple choice. Then you get 15 questions, and you get a calculator, and you get 30 minutes to do that, and that's multiple choice. Then you get 2 free response questions to do in 30 minutes, and you get a calculator. And then you get 4 free response questions, and you get an hour, but you don't get a calculator. So it goes no calculator, 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 no calculator. That's how the exam goes. Okay, so that's it. Okay. Let me go back to here and see which problems you want me to do. Okay, so we've done, was this the third problem? Can't even see anymore. I can't tell. Was this the third problem? The one we just did? That's what we just did, right?
Yeah.
Okay, so now I'm gonna go to number 8. And you got to skip 5, 6, and 7. So 8, should, I mean, I ideally should have been a gift to you. So one of the things that I had kind of talked about is if you take the derivative of an integral and as a dummy variable, I'll just make this a and make this b, and make this f of t dt. So in a very, very generic way, here's what you have to do. In a very generic way, we go, okay, this is f of b times b prime minus f of a times a prime. Now, notice that if a and b are constants, when you take the derivative, it's 0, so that part goes away. But if a and b are functions of x, as b is in this problem, we would have to just plug it in and then differentiate it. So like if I were doing did anybody have any questions on that concept right there? So if I'm doing something like this one, and I were to write out everything, and I have sine t to the 4th dt, and that extra piece comes from the chain rule, like this piece right here and this piece right here are coming from the chain rule. So like if I'm doing this one, I would do the sine of x to the 4th times 1 minus the sine of 2 to the 4th times 0. Because if I differentiate 2, I just get 0. So in this case, it's just sine x to the 4th. So that problem actually comes every single year. That problem comes somewhere in the middle of the multiple choice questions. And if you don't know how to do it, it's nearly impossible. And if you do know how to do it, it's pretty easy. And generally speaking, the multiple choice goes from easy questions to hard questions. So just like the ACT does, where it starts out easy and it gets progressively more difficult. And usually this one comes either on either right in the middle or on the back half of an exam. So it's supposed to be a really difficult question, but it's really not terrible. If we go to 10, I think there was another one that was really similar to it. Something like this. This is the same kind of problem. So here's the same kind of problem using the same terminology on here. So if you go, well, if h of x is equal to the integral from -1 to x cubed of the square root of 2 plus t squared dt, and this would be quite frankly more like what you'd have on the AP exam, then h prime of x is the derivative of this. Now you wouldn't have to write out what I'm writing out right now. In fact, you should just be able to identify probably what the answer is. Because what this answer is this is the square root of 2 plus x cubed squared times 3x squared minus, and you wouldn't actually have to write this part, 2 plus -1 squared times 0. Again, because the derivative of -1 is 0. So really the answer is this part right here. And you could see that that's this last one down here, right? That's D. That's the answer down there. I think if I scroll out, maybe I'll see. I don't know why I'm not seeing the letters anymore, but that's D. That's this one right down here. And so if that's how fast that problem should be. Like you're supposed to get 2 minutes per question. This is a question that literally should take no more than about 30 seconds. Really, it's a pretty quick one. What that means is it saves you for some other ones later on.
Mr. Alquist,
Yeah.
can you go back up to the last one that you did? Because like, why on that one, if you have x to the 4th, is it just, then why is it just 1 after it instead of like differentiating it or whatever, like you did in that one that you just did?
What's the derivative of x?
Oh, you're right. Never mind. I was thinking I have to do derivative of x to the 4th.
No, because what you're doing is you're plugging it in here, and then this is the derivative of
Okay. Yeah, that makes sense.
x. So that's where that's 1. Yep.
Cool.
And that's where, and that's where we do that same thing here, where we plug this in here, and then this goes, and then that's the derivative. Yeah.
Yeah. Okay. Thank you.
Yep. And admittedly, I mean, I don't even think that it'd be pretty hard pressed to see a problem like number 8 on the exam, because it's pretty easy, and you could almost fall into that one pretty quickly. Where most of the time they're more like 10, to be honest with you, where the bound is not just x.
Okay.
That's all you have to do. Sometimes the bound is x, but like it was here on this problem, and knowing that when the bound was x, that we just got this, but then we had to interpret things off of a graph and such. That would be more like what that would be. But if it's just a standalone problem like this number 10 is, that's more along the lines of what AP would do rather than something like this. AP would put 10 on there way more often. Okay, so remember, I keep on kind of hammering home that the chart is a monstrous thing, right? We've been doing things with the chart for about 2 months now, and so what is the least possible number of critical points? So you got to remember, critical points. So critical points for F are when F prime equals 0, or when F prime changes signs, right? I mean, you're going to get a critical point. So again, here's the kind of the situation. So this is using actually the same kind of concept that we have. So you got this f of x, and it equals the integral from 0 to x of h of t dt. So f prime of x is equal to just h of x. So if we need to know when this changes signs and how many times, then we also can just figure out when this changes signs. And notice when you go up here, h goes from 16 to -8. So there's got to be a critical number somewhere in here. There could be more, but that's why it says what is the least possible number. So you know there's going to be one that exists right here. And then it goes -8, -9, so that doesn't really give us any information. -5, that doesn't give us any information. But then we go to 7. So there's got to be another critical number in there because we're going from negative values to positive values. And then we get to 27, and that doesn't tell us anything. That's why the answer is 2 on here. Because we're looking for how many times this happens, which is how many times that happens, and we can see that changing signs 1, 2 times for sure. There could be other ones in there, but we just don't have enough information to figure out if there are other ones. And we don't really care because that's why it says the least. Any questions on that? All right, the last question you guys had was number 15. And so we got a piecewise function, really similar to what we did with delta math. You go from 0 to 8 of f. So this is almost exactly kind of the question that we had from delta math. So let me write something out, and then I'll show you what I'm writing out. So the integral from 0 to 8 of f is the integral from 0 to 2 of f of x dx, plus the integral from 2 to 3 of f of x dx, plus the integral from 3 to 8 of f of x dx. So these two things are the same. These are the exact same things. Because, and in a piecewise function, we just have to divide it up. So if you think about like what that looks like, that means we have the integral from 0 to 2 of 2, plus the integral from 2 to 3 of 3, plus the integral from 3 to 8 of -1. So those are pretty easy integrals, except some people get kind of confused. Well, what's the integral of 2? Well, if 2 is the derivative, it came from 2x, right? If 3 is the derivative, it came from 3x. If -1 is the derivative, it came from -1x. So this is equal to 2x evaluated from 0 to 2, plus 3x evaluated from 2 to 3, plus -1x evaluated from 3 to 8. And now it's an arithmetic problem. Right? Now we got 2 times 2 minus 2 times 0, plus 3 times 3 minus 3 times 2, plus -8 times, or -1 times 8 minus -1 times 3. And then we just do the arithmetic involved with that. So that was really similar to the one if you want more practice on a problem like that, you could go back to the delta math and do some more problems. What else can I do for you? Because I still obviously have some time. Don't beat yourself up if you didn't do these, if you got some of these wrong and you're like, oh my God, I can't believe I missed those. You're going to see really similar problems on my exam and on the AP exam. And they're not terribly difficult once you've seen one of them and made a mistake on one. and you get the same kind of problem next time, you'll be like, oh, well, this isn't so bad. I've seen a problem like this. I know what I did last time. I'm not making that mistake again. So I've done all the problems you guys wanted me to do. I'll do more if you need them. Otherwise, you're free to go. Have a great weekend. Get the other one done. Get caught up this weekend. I implore you to get caught up.
Thank you, Alquist.
You got it, my
Thank
friend.
you.
Thank you.
Oh, good.
Have a good weekend.
All right, see you guys. Have a great weekend.
Hey, are you gonna let us watch March Madness next week?
Benny, you gotta stop slacking, bro.
Hey.
Seriously. Hey,
No,
I don't even
Hey.
know who won. I had to turn off the Florida game.
Florida won.
I gotta-
Florida.
Florida did win overtime.
Yeah.
Hey, if you want to see a winning bracket, you can just look at mine.
Nope.
Oh yeah. Who you
Yeah.
did you pick Gonzaga? Everybody else picked Gonzaga.
Yeah, dude. Honestly, who didn't pick Gonzaga to win?
I didn't pick Gonzaga to win. I
What?
picked Illinois to win.
No way.
Oh
Have you seen that dude? That big 7-footer for Illinois? That
no,
man is a
it's just
beast.
because Alquist has to be loyal to the hometown.
No, I'm a Big Ten fan. Like I
don't
would,
even have-
I have a hard time picking any SEC team past the first round. I mean, I know that
Really?
they might win the first round, but even if I think they're going to win, I just can't get up with picking an SEC team. Like, who's going to
Mr.
pick
Alquist.
Alabama to win? Everybody hates Alabama.
Mr. Alquist, I made the dumbest mistake on 2 of them. I could have had 12 out of
Yeah.
12.
I should have had like 13 out of 15.
So
I
the
know.
good thing is, like, if you miss them now, that's the time to miss it, right? I mean, like, you don't want to make those same dumb mistakes
Yeah.
next week. Like, if you miss them now, who cares, really? I mean,
Yeah.
other than you just kind of, your pride's a little hurt, maybe, but
Yeah.
but really, you want to not make it the same mistakes next time.
Yeah.
Like anybody who missed that one where you just have to take the derivative, like number 10, I guess it was. I think it was, and there's a lot of people that will miss that this time, but they won't miss it next time.
Yeah.
They'll be like,
Like
oh,
on
I'll
number-
hammer that one now.
Yeah, like on number 1, I forgot to multiply like f of 3 and f of 5 and f of 7 times the width. So I got like,
Yeah.
I got 6 instead of 13. And then on 10, I like, cause on 8, I got it right. Cause I got like sine x to the 4th, but I forgot that you had to like differentiate it. So I got
Right.
just like 2 plus x to the 6th instead of the square root of 2 plus x to the 6 times 3x squared. So I just made like
Right.
2 bad mistakes,
And,
but I
and
could have
you
had them
will,
all right then.
but I can tell you that there will be a problem. Really, I mean, different letters and different equation, but it'll be really
Yeah.
similar to number 10. And
Yeah.
and you'll see it on the AP exam, so I can guarantee that you'll see it on my exam, and you won't miss it then. You'll be like, oh, this is easy. Like literally that
Yeah.
question will be like a 20-second question.
Yeah.
The only thing you got to
Yeah, it
do
was
is
just
you
like-
got to be kind of careful, because one of the tough things about AP is they will put up a plausible wrong solution. Like this one is just like, for any bonehead that just decides, well, I'll just write this same thing down. This one's for making the mistake of plugging x cubed in, but not differentiating it. This next
Yeah.
one is saying, okay,
That's
well, I
what I
know I
did.
need to differentiate it, but then if they don't read that this one's squared and this one's to the 6th,
Yeah.
you know, it'd be easy to, in the heat of the moment, for a student to throw C down there for an answer, you know?
Yeah.
So, yeah, it's not so bad.
The thing today, the multiple choice today I started, it's like all
Mhm.
use substitution and stuff.
Oh, is it? Yeah.
Not like all of it, but there's a decent amount of it. And it's nice because they don't make you actually like solve the whole thing. They just make you like do like half of it, and then
Right. And that's the way they'll do it on like a calculator or a no calculator question. Like they'll put that kind of a question on the calculator exam, because even though you have like 15 questions, like on the real test, you have 15 questions that for multiple choice that are calculator based. Honestly,
Yeah.
out of the 15, like 8 of them will be ones that you don't need a calculator to solve.
Yeah, I was gonna ask you
So-
that, like for the calculator part, like, will you,
Yeah.
like, will you have to use the calculator, or like will some be able to just do them in your head?
A lot of them will be like this one, that one number 10 that we did, that one might be, I've seen that one put on a calculator exam, right? So you just have to,
Yeah.
you just have to know how to do it. So there's a lot of them. There's like out of the 15, I think there's a good 8 of them that you never would even touch your calculator on them. So you can just do it, or maybe you touch your calculator, do like some arithmetic or something, you know.
Yeah. All right. Thank you, Mr. Alquist.
It'll be good to have both of you in class like every day.
Yeah, it's gonna be
Right?
fun.
That'd be
Yeah.
fun.